looking at the chart for today.
Professor.
Oh, we have 6.3, 6.4, Marielle, you gotta turn your mic down. Marielle.
Did you mark me here? I'm here.
No, I marked you gone. No, I got you. I got you. You're good, man.
I'm here too, Dr. Wickman. Angela Humbert.
Angela.
Yeah.
Let's see. I don't have you down here, Angela.
Yeah, I had to fill out the form today to get back in, so I don't know if it'll be showing back up by Monday.
All righty. So are we on track for that?
Yes.
I still have you at 2482?
Yes. Mm-hmm.
No. All right, Mary Ellen, that's good, everybody. That's all right, now let's see if we can get to where we need to go.
Dr. Wickman, I'm here as well. My name is Elena Villalpando.
Can you spell your last name?
Villalpando. V-I-L-L-A-O. Okay.
What does it start with?
With the V.
Oh, Selena?
Selena. Yes.
Yeah, I got you.
Oh, okay. Thank you.
You say that so perfectly. I have to practice that myself. I'm not very good at that. I like that.
Thank you.
Oh, you're good. I wished I could be that good. So yeah, that's good. All right. So we're trying now to get into the book. Can you guys get into the book with this?
Yes.
No. Still there. Okay. And this thing is, can you still see me and hear me?
Yes, you can.
I can.
Okay. We're going to six. Does anybody know what page we're on? We're on 6.3, but does anyone know what page that is?
680, 6.3.
680.
I'm sorry, 383.
Is it 383?
Yes.
Lizeth, right?
Yes.
All right. So let's go and see if you can see it now. Hopefully you can. Tell me you can see it.
Yes.
All right.
Yes.
Does anybody know what this is a picture of here? Does anybody know what that thing is there? Nobody?
No.
Pyramid?
I don't know.
What'd someone say?
A pyramid?
It is a pyramid. But it's the entranceway to something very famous. What is it?
I know it's the same architect as the museum downtown Dallas, but I don't know where it is.
It's in Paris. It's the Louvre, a very famous art museum where the Mona Lisa is. All that it's down there. It's huge. This is just the entranceway, but it's all everywhere. Like across the street there, that's part of it.
Oh, really? That's nice.
I think it was in that movie with Tom Hanks.
Yeah, that's right. That's right. So, this is 6-1. We need, did I pull up the wrong one? It's supposed to be what? On the wrong page?
It's
383?
383.
Yeah. Okay. Nothing's quite working right today for me. Number one. Have we not had this before with this group?
No.
Oh,
So when you multiply something, there's like 40 problems in this chapter. The square root of 3 times the square root of 5 gives you square root of 15. It all stays underneath the root. The second one, you take the 5 times the 2, you get 10. You can't do anything with the AB, so it just stays AB. So you see it equals the square root of 10 AB. Now, you can only do that with the like roots. Notice the next one is a cube root. That cube root says you have the cube root of 4 times the cube root of 5. That gives you the cube root of 20. Now, if I asked you what that number was, the cube root of 20, you should be able to go to your calculator and figure that out. Now, again, just as a reminder, let's see if our calculator works. And everything's been blowing up today. So if I go to the calculator and it blows up and I have to come in, and I may have to, you never know, just the whole day has been like that with this thing. So cube root, I'm going to go to math. Boom. Cube root is number 4. Hit number 4. Now I'm going to put 20 in there. I'll push it out. I'll hit enter. That's going to give me the number. Cube root of 20 is about 2.714. I want to also show you something. This is what the next thing was. They're going to try to do this. Mary Ellie, did you have a question? Good. All right. So let's say we have the square root of 4 over 9. That's the same thing as saying the square root of 4 over the square root of 9. The square root of 4 is 2. The square root of 9 is 3. So I just want to point this out. It's an important differentiation. And back to the book. I guarantee you this thing is going to fail sooner or later. Number 5. 5 has 5x. Now, what they did to this one is they converted the square root of 5x to a exponential notation, to a fraction. Because that's the same thing as saying there's a 2 technically in front of that square root, so it's 5x to the 1/2 power. 3y is to the 1/4 power. So you can multiply them. You could take 5 times 3, which gives you 15. Or you could do it their way, which is you can add the 1/2 and the 1/4. You get a common denominator. It gives you 3/4. So you have 5x squared and 3y to the 1/4. All of it's to the 4th power. This is kind of a tricky one. So look between line 2 and line 3. They use the 2, which is the numerator, and they use the 1, which is the numerator for the 3y. You just don't see the 1 there. It's there. And then everything, since they had the same basis in terms of the exponent of 4, they put it to the 1/4 power. Now, you can multiply the 5 times 3 or 5 squared it first, because it wouldn't have mattered. But yeah, you want to do parentheses first. That's 25 times 3 is 75. The x squared and y cannot be done anything with, so they multiply, as you can see in the bottom line. Now, it stands for the 4th root power. So all those steps look like it comes out fairly easy, but it's not. This is a complicated level 4 or 5 problem. The hardest part was looking at 5x square root, the second line, and converting it. Once you do that, you know you can add exponents. Once you add the exponents, you can go from there. So 5, I want to point out, Is there a question about number 5? There might be. I know I spoke on it a long time. Let's go to number 6. That was a hard problem, and I appreciate anybody that works and gets that. That's good. Now, number 6, they're factoring. They're simply looking at the number 50, and they're looking for the largest root out of 50, largest square root possible, and it's 25. Because 50 times is equal to 25 times 2. So you can take the square root of 25, it's just 5. You take the square root of 2. You get 5 square roots of 2. Cube root of 32 is, you look for the first cube that you can find in 32, and that's 8. 8 times 4. Cube root of 8 is 2, which leaves you inside the root, the black number, cube root of 4. So 2 times the cube root of 4. Number 8. It's a 4th root. So look at 16, because 16 times 3 is 48. How do they get that? We took 2 times 2 times 2 times 2, which is 16. And you get the answer. You won't find many of these, but there are clues to look for. If they're a 4th root, it's got to be a small number like 2 times 2 times 2 times 2. Because 3 times 3 is already 9 times 3 is 27. And you do that again, you can't get 48. Looking at number 9. You can take the square root of x squared, but not of the square root of 5. Now, this should really read x times the square root of 5 because x usually is first. They have it square root of 5x, but it's the same thing. Next page. Again, at any time, if someone has a question, raise your hand, that'd be good. So now they're only going to get a little bit more complicated. The square root of 18 is 9 times 2. You can take the square root of x squared, so you're going to pull out the 3 and the x. And then you're going to get the square root of 2y squared to the root. So look at number 10. You know x squared is going to be an x, so that's already automatic. 18 is 9 times 2, so you know you're going to get your 3. And the rest stays underneath the radical. So 216, problematic in the sense you got to find something that goes into 216 square. Well, the first square you can try is 4, and you can try 9, and you can try 25, 16 you could have done, and so on. After 5 comes 6, 36. 36 does go into 216, 6 times. So the square root of 36 times the square root of 6 gives you 216. You take the square root of x to the 4, but because it's 5, but you'd still have 1 left over, so it would give you 2. Because 4 divided by 2 is 2. Y cubed is going to give you 1 square, because the 2 has to match 2, you get whatever's inside the y. Would you guys like me to do 11 on the whiteboard?
Yes.
Okay. Let's
Why
do
do
that.
they separate the X4 and the
Because
X?
I'll show you. 216 x5 y3. Okay, so let's look at this one. Let's break this one down so it makes sense. So you guys feel good about it. Or better. I don't think I feel good about it. So they give us the square root of 216. Y to the x to the 5th. And y cubed. And they want us to take the square root of all that. Well, we know, for example, 216 has the square root of 36 times the square root of 6 times x to the 5th is the same thing as saying x to the 4th times x to the 5th, or x1x rather. And y cubed is really saying y squared times y. Like that. The reason why I did that is because remember there's technically a 2 here. Right here. So that means we're taking the square root. So the square root of 36 comes to 6. But we still have the square root of 6 left underneath there. The square root of x4 is x squared. We still have an x left from here. So that's the root of x. Y squared becomes y. With the square root of y left there. So from here to here, ask me any questions. That's the one part you got to get.
You're just dividing by the square root, right? Or if it's cubed, you divide cubed.
Wait 1 second. Is Miss Johnson in here? Kira Johnson? Hold on. I have a student that's trying to get in. 41. 1 second, class. Okay, so what was your question again? I'm sorry.
You're just dividing. If it's squared, you divide by 2. If it's cubed, you divide by 3.
The root or the exponent you do.
Root.
That's correct.
Okay.
So look at the second line here. The square root of 36. You take the square root of that 6. Now x4, the third part of it, we divide the 4 by 2 and we get x squared. That's right, we divide it by 2. Y cubed, you divide by 2, you get 1 with 1 left over. That's what you get, you're right. So now, in this third line, we have to consolidate it the way it's done properly. So we do have 6 square roots of, let me write that again. You have a 6, you have an x squared, and you have a y. And left under the radical is a 6 and an x and a y. This is the final answer. The whole numbers come out front. There's the 6, there's the x squared, here's the y. What's left over is the root portions. They stay back underneath it, and here they are. Does that help at all? Anybody? A little bit?
It did.
This is kind of a hard one, 216. The next one. 13. Multiply and simplify. Well, look, the square root of 20 and the square root of 8. Let's just do that ourselves. Try another one. These are multiplied together. Now, we're looking for a square root in 20. That breaks down to the square root of 4 and square root of 5. We're looking for a square root in 8. That breaks down to the square root of 4 and the square root of 2. You know the square root of 4 here is 2. The square root of 5. The square root of 4 is 2. The square root of 2. We can multiply these two numbers together, which 2 times 2 is 4. And the square root of 5 times the square root of 2 gives the square root of 10. That's how it's broken down. Question about this one. Anybody good?
Yeah.
Hoping method that makes a little better sense. Oh, so that was 13. 14 and 15 are the same things. It's more complicated. You're looking for cube root in 18. And 2 times 3 is 6, times 3 is 18. So there is no cube root in 18, but you get it to be 2 times 3 times 3. 4 is 2 times 2. So notice how they marry those up. You have 3 times the 2's, which matches that number 3, so the 2 can come out front. Notice you have y3, it matches that 3, so y comes out front. X squared is length and left over. It's not big enough, it doesn't stay out front. So that's 15. 15 is very well explained here. 18, we broke it down to 2 times 3 times 3. That's 2 times 9. 4 was 2 times 2. Why? Because we're trying to get 2 times 2 times 2's. Go to 16. There are like 40 questions in this thing. I'm not sure. A long list of them. And everything's been freezing up today. I don't know why. Maybe it's because it's Wednesday. Some people are meeting. So look, this is another little trick. You have the square root of 80 or the square root of 5. So you have the square root of 80 over the square root of 5. You can rewrite the top number as the square root of 5 as the square root. We have to multiply 5 by to get 80. Does anybody know? We know that it's 16.
Yes.
All right. So we can take these and cancel. Now you have the square root of 16. The square root of 16 is equal to square root of 4. What is simply 4? And let's see if that's so. And there it is, 4. And all you're doing is looking for parts that match. 18 is probably the most complicated one. Let's look at that one for this. That gives you the square root of 72xy all over 2 times the square root of 2. Now let's see how I would think about it, and hopefully you guys will agree. So we said we had the square root 72. Was xy underneath it as well?
Yes, yes.
Under
Over.
XY.
right?
Yes.
Yeah.
Okay, so this is the square root of 2 here. So in the square root of 72, we got to look for a square. That's in 72. So we can use our calculators. We can try to find it, see if it's divisible. We can try. We know 9 goes into it, 9 times 8. So we're trying to get a 2 out of it. So we could say it's the square root of 9 times the square root of 4 times the square root of 2. That's what 72 breaks up into, times the square root of x and y, all underneath it. All this is over 2 the square root of 2. Again, we took 9 times 4 times 2 gives us 72. Right away, we can cancel these two. Because whatever you do top, you do bottom. Now you have the square root of 9, we know that is 3. Square root of 4 is 2 times 2 times square root of x, y. Still have 2 in the bottom. You cancel these out. This leaves us 3 times the square root of x, y. Any questions about this one? Tried to make it easier to understand. And I think that's the answer. I hope, is that the answer the book gives? 3 times square x, y? I guess I'll see you. Lizette, you're my book person. Are you okay?
Yes, I am. I'm sorry. I can't get in. I'll try.
3 times the square root of x, y. You're good. All right. So all the rest of it.
That's what the book has.
Let's look at 20. 20 is the next hardest one. This is pretty simple. The square root of 25 over the square root of y squared. The first thing you're taught is that you break it up. You have the square root of 25 on top with the square root of y squared on the bottom. The square root of 25 is 5. The square root of y squared is y. Boom. Pretty easy. Then once you start breaking them down and looking at them, they can get easier and easier. Now, going to a different concept is 23. Oh, it's pretty, I don't like that example much. One. But let's look at 21 because this is the same thing as 23, only they're dividing it. So again, the first step in 21 is you break it apart. So you have the square root of 16 x cubed on the top and the square root of y to the fourth on the bottom. Well, the square root of 16 is 4. The square root of x squared is x. You have the 4x and the square root of x on the top. As someone mentioned earlier, you take the 4 on the bottom, divide it by the 2, and you get y squared. So that one's a little bit easier to understand once you break it apart. 23 now, what they do is this. What they do for that is they use fractional exponents. So a squared underneath the cube becomes a squared b fourth to the 1/3 power. It's all in parentheses. The bottom, the number up front is 2, so you have ab to the 1/2 power. Now let's look at the second line. So a becomes a to the 2/3 power because you multiply it out. B becomes b to the 4/3 power because you take 1/3 times 4. That's the top line. The bottom becomes a to the 1/2 and b to the 1/2. Now, you know that when you have division of exponents, it's the same as subtraction. So you got to take 2/3 minus 1/2. Common denominator is 6. So that's 4, 6 minus 3, 6, which is 1/6. You can see that's a to the 1/6. You have b to the 4/3 and b to the 1/2. Again, 6 is the common d. So that's 8/6 minus 3/6. Or you could say 4. For the b, you can see it's 8/6 minus 3/6, which gives you b to the 5/6. Now, that's the third last line. They just get that by subtracting the fractions. So if you package the a and the b together, a is to the first power because that's the numerator, b is to the fifth power because that's the numerator, and all of it's to the sixth root, or 1/6. Then the last line, if it's to the 1/6, you put the 6 there. 23 is an excellent problem for understanding everything. All right. We need to move on. 6.4. Does anybody know what page that is?
It's 389.
Is it really?
Yes. 389.
All right. I'm thinking that's right. Pretty close. I always like to go right where the first problem is. And here it is. You have 6 square roots of 7 and 4 square roots of 7. 6 and 4 is 10. That's like saying 6 apples plus 4 apples gives us 10 apples. So the next one. They're not apples, they're square roots of 7. 8 cube roots of 2 minus 7x cube roots is problematic. They're not the same. You have cube roots, but the 7x changes things. So 2 is a complex problem. Notice that all of these have cube roots of 2 associated with them. So using the distribution property, you can factor out the cube root of 2 like they do in the red on the right-hand side. Then inside you have still left the 8, the minus 7x, and the 5. Any questions about 2? Because that's an important concept. It's not easily seen at first, but after a while it is. Anybody got a question about number 2?
No.
Thank you. All right, number 3. Same sort of problem. 2 of them have fifth roots. So you have 3 fifth roots of 4x and 7 fifth roots of 4x. Notice 5 roots of 4x for the first 2 is the same. So let's say 3 apples plus 7 apples. You get 10 of those apples. And you can't do anything with the cube root of 4x, so it just stays there, and that's number 3. So the only thing you can add is the common components. So the root must be the same, 5 and 5, and inside must be the same. It is. If that was the fifth root of 6x, you could not add them. It has to be 4x. It has to be the exact same thing. Now, on number 4, they just convert that square root of 8 to 4 times 2, which is 3 times the square root of 4 times the square root of 2. 4 is 2. You get 6 square roots of 2. So 3 square roots of 8 boils down to 6 square roots of 2. Minus the 5 square roots of 2, that's having 6 apples. Minus 5 apples, you get 1. Number 5, there's nothing that you can do. They're not the same. Let's jump to number 7. So now we're going to do distribution. If you have the square root of 3 times x, that gives you square root of 3x. If you take the square root of 3 times the square root of 5, that notice that's a negative. So you get a negative square root of 15. Pretty easy. Eight is kind of interesting. You take the cube root of y times the cube root of y squared, you get the cube root of y cubed, and notice if the 3 matches a 3, you get y, whatever's inside. Second part, cube root of y times 3 square root of 2 is your 3 times square root of 2y. Nothing you can do about that. These are all kind of tough, man. Now we're going to do the FOIL method. I don't want to do 9 first. I'm going to do 10. 10 says you have the square root of a plus square root of 3 times the square root of b plus the square root of 3. So I'm going to show you this one. Again, the problem was square root of a plus square root of 3 and the square root of a. Mary Ellie, do you have a problem issue? Square root of a and b plus the square root of 3. Now using FOIL, first, outer, inner, and last. I'm going to take the first two. The square root of a times square root of b gives you the square root of ab. Square root of a times the last one gives you the problem. Can you check? Is it the square root of a plus the square root of 3 for the second one, or the square root of b times the 3?
Square root of
This one right here, is that an a or a b?
it's B.
Okay.
I can double check.
That sounds right. So then the next one is going to be the square root of 3a. Why? Because this takes the first one times the last one. This one, the middle one, using FOIL, the inners, is the square root of 3b. And the last one is the square root of 3 times square root of 3. You get whatever's inside, that's 3. This is the answer I get. You cannot add any like terms because this is inside. See what the book says. I'm not sure I wrote that down right, but I want to be absolutely sure with you guys. Yeah, the square root of a times square root of b gives square root of ab. Square root of a times square root of 3 gives you square root of 3a. And there it is. It's all right there. It's not very clean. 11's better. 5 plus the square root of 7 might be better. It should say something like this. Square root of 5 plus the square root of 7 times the square root of 5 minus the square root of 7. This is a critical one to know. Notice that they're exactly the same except they're the signs. That means, using FOIL, that there is going to be no middle term. So you simply have the first term times the first term, which is the square root of 5 times the square root of 5, which is the square root of 25. And we all know that boils down to 5. And then the last one, this times this, is going to be minus the square root of 49. And we know that's going to be minus 7. This then equals a negative 2. Now, why is that so? Why is it only the first two and the last two? Because look, you take the middle two, you get the square root of 35. You take the outer two, you're going to get minus the square root of 35. They will always cancel. So anytime you have a plus and a minus situation of the same thing, you only have that middle term. So another example, if you have a plus b times a minus b, the only thing you're going to have is going to be a times a, which is a squared, and b times b, which is a minus b squared. The middle terms always go away because this is ab. This is a negative ab. Hope that helps. Okay. And that's what they did in 13. It's the same thing. Only we have, I don't want to repeat it because it's just a square. It means you multiply it by the same thing again. Let's go to 6.5. Is that what is left? Do you know what that is?
6.5 is 395.
All right, let's see what that is. Oh, by the way, it's called, this is an important term right here. You see in the top of the page, it says a plus the square root of b times a minus the square root of b. They're called the conjugates. What that means is anytime you have a plus and a minus situation of everything being the same, it's called the conjugate, and the middle drops out. Very important term. Almost overlooked it. All right, so there we have it. 6.5. Rationalize the number. This is an easy chapter. Let me again do this one for you. You have here, again, they write the square root of 7 over 3, which is the same thing as saying the square root of 7 over the square root of 3. Now, the rule in math is this. You cannot have a square root in the denominator. We got to rationalize it. We're going to multiply the bottom by the same thing then. But whatever you do the bottom, you got to do the top. When you multiply this by itself, you get the square root of 9, which is 3. So anytime you multiply two square roots by the same thing, you always get whatever's inside. The top becomes the square root of 21. That's the answer. So anytime you have a radical, let's just do 8 over the square root of 2. You would multiply the bottom by the square root of 2, and then whatever you do the bottom, you got to do the top. You get whatever's inside on the bottom, that's easy, and you get 8 square roots of 2 on the top. That's all you're doing here. Now, they can make it a little more complicated, and that's where the conjugate's going to come in. Go to the next one. Can the cube root is the same sort of thing. The first thing they do is they break it apart. Then they add to the bottom. So I don't want to go over example 2 lightly, so I'm going to do that one again for you too. Cube root of 7 over 25. So let's take a look at that. Selena, do you have a question? Sometimes you guys are I'm getting hands popping up here. Just want to make sure I do right by you guys. So anyway. All right, we had, that problem was the cube root of, I wrote that down here somewhere, 7 over 25. That's equal to the cube root of 7 over the cube root of 25. But now the bottom is really, in fact, the cube root of 5 squared. Now, in order to get this number out of the cube root situation, we need this 3 to match this number on the right of the 5. We need it to be a 3. We've got to multiply the bottom by another cube root of 5 to the 1. Whatever you do the bottom, you got to do to the top. Again, if this number matches this number in the bottom, you simply get 5. You can't get anything else but a whole number because that's the whole purpose. The top then becomes the cube root of 35. Why? Because 7 times 5 is 35. Again, all we want to do is make these two numbers match. Make these two numbers match, life is good. That means you have the cube root of 5 cubed. Anytime you have these numbers match, you get whatever's inside. That's why I multiplied by the 1. So that one. That's why I didn't want to take that one lightly. Maybe I wasted your time by doing it, but I felt that some people might benefit from that one. Go to the next page. Again, to rationalize the denominator, the first step is they separate these complex fractions. See the square root of 2a over the square root of 5b. So they multiply the bottom by the same thing, so you get whatever's inside, 5b. Whatever the bottom, you do the top. 10, the same thing. We just did a cube. This is the cube root of a over 9x. So let's do that one. We'll do that one too. Written, the cube root of, was it a over 9x? That's the same thing as saying the cube root of a over the cube root of 3 squared x. Now we got to get the numbers on the bottom to match the root number of 3. So we're going to multiply by the cube root of just 3 to the 1, because 2 plus 1 is 3, and x squared. You know, on the bottom, it's automatically going to give us 3x. That's what the whole purpose is. Whatever you do the bottom, you got to do the top. Cube root of 3x squared. And if that's an a, you then have a cube root of 3ax squared. The whole idea is to get a whole number in the denominator. And there it is, cube root of 3x squared over 3x. I know the number of the a. Here's how you put the right order, by the way, at the end here. The number always goes in front, and then I put it in alpha order, a, b, c, d, f, g, x. 5 is just the same thing. It's a little more complicated in the sense that it's a fifth root. And the numbers just simply have to match. Now, the problem here is 3 over x plus the square root of 7. This is where the conjugate comes in. We have 3 over x plus the square root of 7. Now, you view this as one term because it's connected. So in order to get rid of that in the denominator, the square root, we got to multiply by the conjugate. Remember, x minus the square root of 7. Whenever you do the bottom, you got to do the top. Now, if you recall, once you have a plus minus situation, it's only the first two numbers multiplied together. It's going to give you x squared. And the last two, which is minus 49. I actually did this one earlier for you. You probably don't remember it. Remember, it's the first two times the last two. 7 times 7 is 49. Oh, and that's the square, so that becomes 7. It's a minus 7. That was under the square root. X times x becomes x squared. But when you take the square root of 7 times square root of 7, you get square root of 49. And that becomes a minus 7. I just didn't put the square root in there. I should have, but there you go. You can see that. Now the top is 3 times that, which gives you 3x. And this times this gives you a minus 3 times the square root of 7. That's your answer. Now, they didn't even do it. All it did was show you what to do. Now, they did number 8. Let's you and I go to do number 9. Or I did one they didn't even do. Square root of 2 over the square root of 5 minus the square root of 2. This is about as complicated as it can get. I'm sure they'll come up with something more complicated. Let's see. So we have looking at my notes, where are my notes? 4 plus the square root of 2 in the top over square root of 5 minus the square root of 2 in the denominator. And we know we're going to multiply by the conjugate, which is the square root of 5 plus the square root of 2. Remember, we do the bottom, we got to do the top. There's our equal sign. We know the square root of 5 and the square root of 5 is going to give us 5. And the square root of 2 times the square root of 2 is going to give us 2, but it's minus 2. So the bottom part is clearly going to equal a negative 3. Excuse me, a 3. 5 minus 2 is 3. Now the top part, this times this, so the bottom part is going to be a 3. 4 times that gives you 4 square roots of 5. This times this gives you 4 square roots of 2. This times this gives you square root of n. 2 times 5 is n. And the square root of 2 times square root of 2 gives you 2. So the top part is just this part, 4 different components. The bottom is 3. Now let's look at the book. The comparison. So they multiply by just exactly what I said. Look at the bottom, ends up with 3. 5 minus 2 is 3. The top is everything that we said it would be. I hope I made it look simpler. But this is what you do. The red part of the first line is the conjugate, which means you're going to get 5 minus 2. They don't show that work all the way till the second last line, and that's 3. I worked it out just to keep your brain focused on the denominator, but I focus on the numerator. Well, ladies and gentlemen, that's it for tonight. It's a lot of stuff, and Zeth, if you can hone on for next class to ensure that we start at 6.6.
Yes, I can.
And that will
I'll
be
write it
great
down.
to get that page number. I appreciate you guys' patience. Any final questions? Let me check again. Anybody joined that wasn't here before? They marked in that I don't have a time for. I think I got everybody covered. Oh, wait. Yasina Quintana, are you here? Oh, Yasina. How about Daniel Ramos? And that's it. You guys, thank you all.
Good night, Dr. Wickman.
Jerry,
Good
thank you
night.
again.
Thank you.
For everything. Lisette, thank you guys. Angela, everybody.
Thank you.
Appreciate you all. Thank you.
Thank you.